Now the next question is question number 16. If y is equal to square root x minus 1 over square root x, then you have to prove or show that 2x dy by dx plus y is equal to 2 square root of x. So actually we have to just apply or calculate this dy by dx, and then we try to prove this result. So first priority is to solve or to calculate this dy by dx. Solution: given that y is equal to square root x minus 1 over square root x. Now that can be written as y is equal to x raised to the power 1 by 2 minus x raised to the power minus 1 by 2. Applying derivative on both sides, that will become dy by dx is equal to d by dx will apply on both of these two parts, x raised to the power 1 by 2 minus x raised to the power minus 1 by 2. Using our sum or difference theorem, derivative will apply separately on both of these two terms. So d by dx will apply on x raised to the power 1 by 2 and derivative will apply on x raised to the power minus 1 by 2. Now that will become, by using our power theorem, 1 by 2 x 1 by 2 minus 1, which will be minus 1 by 2, plus, this plus is actually like this minus 1 by 2, and this minus will become plus 1 by 2 x raised to the power minus 1 by 2 minus 1. So if we explain it separately, then so this is actually 1 by 2 x 1 by 2 minus 1 minus, by applying derivative on this portion, so by using power theorem, minus 1 by 2 x raised to the power minus 1 by 2 minus 1. So now we have 1 by 2 x raised to the power, this 1 by 2 minus 1 will be minus 1 by 2, and this minus and minus will be plus. So 1 by 2 x raised to the power minus 1 by 2 minus 1, that is minus 3 by 2. So that can be written as 1 by 2, by shifting it to the denominator, that will become a positive power 1 by 2, and similarly this can be shifted to the denominator and that will become plus 3 by 2. 1 by 2 x raised to the power 1 by 2 plus 1 by 2, this x is actually 3 by 2 can be separated into power 1 and 1 by 2, so that can be x into square root of x. 1 by 2, this x 1 by 2 can be written as square root of x plus 1 over 2x into square root of x. By applying LCM, that will become 2x square root of x, and here we have 2 square root x will be cancelled out, we have x, so this x is after multiplication by 1 plus, and that portion will be cancelled out, we have only 1. So multiplying both sides by 2x dy by dx is equal to x plus 1 divided by square root x. 2x dy by dx will be as it is equal to x can be divided by square root of x and 1 divided by square root of x, and this actually we divide this square root of x, both of these two terms, x and 1. So now we have 2x dy by dx is equal to x divided by square root of x will be square root of x plus, and this will be as it is 1 over square root of x. 2x dy by dx is equal to 1 over square root of x plus square root of x, almost the same work, but just shifting these two terms. 2x dy by dx is equal to minus square root of x plus 1 by square root of x plus square root of x plus square root of x. Actually we just apply adding So here just we apply actually adding and subtracting square root of x. So this is actually this square root of x with subtraction, and this one is by addition. So 2x divided by dx, when we take common from minus from these two terms, square root of x and 1 by square root of x, that will be positive square root of x minus 1 over square root of x, and this will be 2 square root of x. So 2x divided by dx, this is actually y as we mentioned here. So minus y plus 2 square root of x, and now this minus y can be shifted to the left side, so that will become positive y is equal to 2 square root of x, which is actually our required result. So this is, so the next question is, if y is equal to x4 plus 2x square plus 2, then prove that dy by dx is equal to 4x square root y minus 1. Again, just we have to calculate this dy by dx and try to form this result, 4x square root y minus 1. So solution, given that y is equal to x4 plus 2x square plus 2. By applying derivative on both sides, this will become dy by dx, and dy by dx will apply on x4 plus 2x square plus 2. Again, using our sum theorem, derivative will apply separately on these three terms. So derivative of x4, derivative of 2x square, and derivative of 2. So by applying derivative on x4, that will become 4x raised to the power 4 minus 1, which is 3, plus this 2 will be come out to the derivative. Derivative will apply only on x square, so which is 2x, plus this one is constant term, so derivative of 2 will become 0. And this is actually 4x cube plus 2 2s are 4x, and we can take common 4x from these two terms, so we have only x square plus 1. Actually this one is dy by dx. Now we are going to prove our this result, and if we see our required portion, we have 4x. Now we can take 4x common from these two terms, then we have x square plus 1. So now our next requirement is 4x into square root, which is not actually here. So when we apply square root of x, then we have to take square. So actually, just like we applied adding and subtracting in our previous question, we actually apply square root and this square to this portion x square plus 1, so that our required result will become in the required form. So 4x, this square root as it is, and after opening this square, we have x4 plus 2x square plus 1. Now there should be y in our square root portion, and y is x4 plus 2x square plus 2, but we have here only x4 plus 2x square plus 1, so we just missed our 1, and when there is 1, by adding this 1, that will become 2, and we have y in our square root portion. So we can add and subtract 1 on this inner portion of the square root. So that will become 4x, x4 plus 2x square plus 2. Actually 4x square root x4 plus 2x square plus 1. This one is the actually which is in square root portion. Now we apply addition and subtraction of 1, so that will become plus 1 and plus 1 will be 2, and this minus 1 will be as it is. So this is actually our y, the given value. So we have 4x into square root y minus 1, which is our required result. Hence proved.